Thank you very much, sir. I am from the large scale. I am going to the small scale, but I also give about the information on the general behavior of these glaciers. From the published data, that is the you can see from the slide, from the western part to the eastern part. That is this is the glacier melt, and this is the non-melt from the published data. So if you see the drought regions, you will find that increase in the darker part of the blue area. So that itself indicates whether it is the snow or the ice. These glaciers are very important for this western and the northwestern Indian, especially when there is El Nino or drought regions in the region. And this is also total mass. He was talking about that, and similar that it is mass change is happening in the minus 60.3 gigaton from 6 years, which is the most previous estimates. Region-wise mass balance also shows that it is minus 4 to 1.5 in this, and maximum is in the Tibet positive correlation we are showing. So that varies from the geographically from the west to the east. And if you see the altitudinal distributions, basically that very important for that in different glaciers. Elevation change, rate of elevation change from 2000 to 2016. So Western Himalaya, Tibet and Lagos, especially that where we are working in the Western Himalayas, they are the negative mass balance in the recent past, and they may contribute if we allow the flow to continue to the sea, that sea level change will happen, but in Ganges we don't allow Brahmaputra maybe, that is and if you also see that one, that is from the Indian side, if you see that most of the negative mass balance years are 1974 to 2002. On a regional level, the geodetic studies also suggest that the whole western, central and western Himalayas, vast thinning occurs during the last decades. So that is happening in the all the three sectors of the Himalayas. The thinning effect is happening in this region. So you can see the elevation wise, area wise, and decrease in the mass in these things. So this is a very interesting work. Recently the scientific reports they have published. So how this this is in the Uttarakhand and Jammu Kashmir and Himachal Pradesh. They stated from the 1724 from the tree rings, and then they tried to compare the mass changes in this region and the role of El Nino and then the radiations in that one. So they found out that gray area is a region where there is a lot of negative mass balance occurs, that is positive mass balance occurs in these regions, and wherever there is radiation changes in the solar radiation, irradiation changes, that there will be a negative. And then they try to compare it with the present day also, that is recent mass balance studies available in these regions, and then they rebuilt that, and then they found out that the influence of this El Nino and this, they also play a major role. But even though there is a mass gain, but whenever there is El Nino here or the irradiation, there is a loss of mass in this. So and here if you see that one, there is loss of mass in this. They are also compared with our data available in this 15 years data, and this is the longest reception data. This is a very good this idea they are given that we can reconstruct from the tree ring studies and the rainfall and temperature, and then find out how the mass changes occur and what are the factors controlling that one, that we can verify from the present observations of the meteorological data in this. So and then from that they conclude that Uttarakhand and the Himachal Pradesh, a lot of mass has been lost in this from the 1970 2014. In Jammu and Kashmir also they lost, but relatively less. That is reconstructed from that one in these regions. So that, and we are also now trying to do from the small scale to large scale by studying that how it is the role of, if you see the red, yellow and green, you can see that on the green one is having a lot of positive mass in this one, and then the red is the negative mass. So we are now trying to do this in the Himachal regions. And then what is the role of debris? So you can see the debris role, wherever that is the insolation effect, you can see from this in all these glaciers. So we try to do these things to find out that how this behavior of the entire glaciers in this region by comparing the Chota Shigiri as well as using the remote sensing, and then we can try out this. And the debris role has been delineated in this one, in this all these glaciers. So this is the collaborative work we are doing, that earlier one, and this is glaciers we have been working now, and one is in the stock also. We started one glacier now in the last 2 years, and the Kanchanala also started with the SaGHAA, and the Pakshu already we are working with the SaGHAA, and Chota Shigiri with the, and we are continuing this in this region. So this is yesterday was Professor Dimiri was talking. So he has given the diagram how this influence of this Indian summer monsoon reduces, and that's he has said the winter monsoon, Indian summer monsoon, Indian winter monsoon. So how this influences this, that's what we are taking it from him, and how he is telling that how the influence is reaching up to this western Himalayas. So this is what the data available, the longest data yesterday. Ramanathan is also talking that in the Himachal Lahore Spiti Valley. So these are the 4 positive mass balance years. So you can see that one, and then the total mass is around 7, -7 we lost. Now we are having the negative mass balance in this recent years. This year also we are expecting around 4.5 in this region, and then the winter balance also we have calculated. That is helps us to understand how this role of winter precipitation and the summer precipitation in the annual mass balance of this region. And then here also you can see that even elevation, hypsometry and the area, you can see the elevation wise how this. So here typically we are also estimating the volume of water coming into the discharge. That ablation is having a 80% role rather than the accumulation. That is the work we are doing it now in this region. That you can find out from this also how these hypsometrical changes are influencing the discharge in this region. And here also if you see that one, wherever there is a debris cover, then there is a lot of mass is relatively less. You can compare from the data available with us in every year. We are trying to, this one is on the Virja publications. So how this elevation wise changes affecting, you can see that throughout the year the 5% debris cover is controlling that is insolation effect is there. In that you can see that how they are affecting in different elevation altitudes, and then the different surface conditions. You can see that how this winter and summer, this is what we have to do that, but we did it for only 6 months, and then we lost the AWS in this region. So we are having only one AWS now in that region, because the avalanche, the wind has taken away this. And from that we are able to distinguish how the winter, that summer precipitations, even a single day precipitation, for example, that is affecting the albedo and reducing the melt rate. In that, if you see that one, the melt rate, a single precipitation during the summer, which is, and you can see the albedo that is suddenly increased at the one. If there is a larger event of snowfall, then immediately cloudy days, then there is a melt rate will be decreasing. So we have to find out the minute influence of these meteorological aspects in controlling. Whereas if you see here in the downstream, that is a smaller one, snowfall, that is not having much impact as compared to that of the larger snowfall events in this one. So the smaller events in the summer precipitation is having a major role in the mass balance studies in these regions. So we also try to find out the long-term data available from the Aphrodites and other data from using this RCM models and weather research forecasting data, WRF, and you can see that that snow melt, that is the long-term and the 2000 to 2014. From we compare with the percent available data, and the 1955 to reconstruct data from the Aphrodites 55 to 99. If you see the total, we are trying to estimate how much is the total runoff, snow melt and glacier melt is contributing. The trend remains the same, but only they enhance that in the short term there is a large amount of melt coming out from the glacier and snow in this region. So here also we try to estimate how much is coming from the different months in this melt to contribute to the glacier and the snow. So, and then this is the Kulkarni study, which is also told that every rise of temperature we lose the length of the glacier and the mass of the glacier in this region. So the different scenarios, the first scenario itself is 2.6, but that is the worst case. Now we are having only 0.5 to 1, and then so the effect is there. If there is increase in temperature, we lose the length and the mass of the glaciers in this region. And then now, because that lab state estimation is a very difficult thing because we are having only AWS. Now we are trying to put it in every elevation, and also the ground flux. The ground heat flux has not been a major role to play. That is not estimated so far to understand the glacier these things. Now we are now working on this. Maybe next year the thesis will be ready. In this with the FAU, we are working on that one to find out the subsurface role, and also every elevations what is happening, then the distributed energy mass balance. We are trying to work out on this and then extrapolate to the regional scale in this region. So and also we have to try to find out the O17, which is not impacting the temperature is not having a major role except the moisture sources. So from the patio and this snow cover, we are trying to say that because it is in the Pir Panjal range. Yesterday we are talking about the mass dumping in the Pir Panjal when it enters. So you find out that initially the westerlies both are having a similar, that shows that even though the Sauranga Pass is bringing the Indian summer monsoon in this region, and 80% is in Chota Shikari is coming from the westerlies, and Patio is 95% of this moisture is coming from the westerlies in these regions. So we are working on this paper also to estimate from this isotope. The first time as the O17 we are trying to use it. So this is already Paramananda stock. We are working with NCOR and GSI and IAGM in this region. So this is the one that West Brugan, and then the Ferren Brain, that is we started 3 years back in these regions. And this is the team we have been going this for the Arctic. Okay. So here you see that summer and winter, in the summer also there is about around 400 meters, because the height is very less there. The positive mass balance is there. Throughout the year we get the very negative mass balance in this region. So the impact is more in the, this is not a it's not a fjord one, it is like a normal glacier. The meltwater comes and reaches there. But yesterday they are talking about the fjord that is joining that is behaving differently than these glaciers in the Arctic regions. So we hope to continue this in this Arctic to get more information and publications in this region. And so the comprehensive long-term in-situ monitoring of glacier melt in the regional scale to find out the amount of water flowing, and the robust scientific findings to be better understand the complexities and reduce the scientific uncertainties, intra and inter-scientific cooperation. That is what we are trying to do in India now, that with the different agencies, and accurately assess the regional climate and impact of the Himalayan glaciers, incorporate the regional climate models and snow. That is what we tried. Initially we have to expand it more in this and glacier mass balance, energy balance, distributed energy mass balance, analytical balance, ice core studies. That is what yesterday also highlighted, but sometimes we should carry out these things. Thank you.